And welcome back once again, this time for Chapter 8, Cumulus Security, Cloud Computing and Security. Cloud Security, that is. So let's go ahead and jump right in to Part 1. In this part, we are going to just do a quick, brief introduction and look at the history of cloud computing. So cloud computing, overall, just a quick reminder, anytime you see a gray bolded term followed by an orange definition, that is something that you could see on the ISC2 certification. So you'll want to take notes as you watch the video. So, it is basically a model of ubiquitous, convenient, on-demand network access, shared pool, right? What does that mean? It's in the internet. We call it the cloud. It's just a data center that's connected to the internet, right? It is comprised of networks and servers, storage applications, etc. If you never have yet seen the inside of a data center and you get the opportunity, definitely take it, especially as an IT, a person interested in IT. It is absolutely amazing. The hundreds of thousands of computing devices all in one place, the infrastructure, the power it takes, the entire process, the entire system is just absolutely amazing. So really, prior to the adoption of cloud computing, we had the client model, which then went to peer-to-peer, where we shared information between clients, and then we advanced to to client server, where the server served the applications within a local area network. That way we didn't have to back up all these many endpoints. And then finally, here came the cloud. So I think the best example of moving to the cloud was email, when Microsoft did their cloud solution, Office 365. A lot of companies who had email servers locally migrated to cloud email servers. That came with the ability to access from anywhere, to access across multiple devices, and especially for small companies, that tended to be a primary server that they were using, that it was now cost effective because they didn't have to have their own on-prem, they didn't have to manage it, they didn't have to back it up, although they're still responsible, as we'll see in this, for the data itself. So, just because things are in the cloud, folks, does not mean we don't back them up. So, two common examples of things that were stored in the cloud: web servers and application servers. Web servers, of course, those are when we access websites. Those are the Amazons. Web services such as QuickBooks has since moved to a service provider model so that you don't have to download. You're not keeping your important client data. You're not keeping your finance data within your local area network anymore. It is on the cloud. So that's just a couple examples for you. APIs, so application programming interfaces. This is how we now interface with the app. A lot of times these apps provide highly available customization that we can take advantage of to customize the software just for our particular business, our industry, whatever the case may be. So the APIs give us a means of doing that. And by the way, they're not just for applications. There's a whole API set for Cisco Meraki hardware, where we can customize and have it do things, have it run processes that we need for our organization. So, benefits and challenges. Well, benefits, it definitely, became cost effective because now smaller companies who couldn't make those large capital investments in staff, in expertise, in equipment to have access to computing technology that benefited their business, now they just rent that from the cloud, right? There's also the fact that that means that they have a monthly expenditure versus a capital expense that they're having to depreciate over time. So really important. Then came the idea of scalability, where, a small company who may have, 1,000, 2,000 visits to their website 10 months out of the year, and here come the holidays, and they sell something where 90% of their revenue comes during the holiday season. They need, suddenly 50,000 people are accessing their website. Well, through scalability, that becomes easy to do. That way they're paying only for that scalability when they need it. Now, of course, anytime we take things to the cloud, we open up that attack vector for, threat actors, right? So the biggest thing is, and you'll hear a lot of this, one of the biggest thing is we still use lousy usernames and passwords for cloud stuff. And of course, once an attacker gets into the cloud, what else do they have access to, right? So, if you're dealing with a reputable cloud service provider, there's also the fact that they are going to have cybersecurity services that far surpass what small businesses can afford. Okay, so there is an advantage from a cybersecurity standpoint for these companies to put their stuff on the web, but we still need to worry about authentication, especially multi-factor authentication becomes huge because we could be letting a threat actor or an attacker into a lot of data versus a little data that might be stored on our site because, of course, cloud service providers are not just storing our data, they're storing company data for company A, B, all the way through, right? So thousands of companies of data that an attacker could get to. So, it's important for cybersecurity professionals and IT professionals from a business standpoint, as well as an individual, to understand cloud services. When we talk about individual cloud services, we talk about things like, maybe you have Office 365 personally, okay? You probably have it in your business. You have OneDrive in your business. Personally, you might have iCloud storage for your pictures, and you need to know what that means, right? Is Apple really responsible? If somebody happens to get in and delete all your pictures, are they responsible for restoring it? You should look. You should know, because today we're storing a lot of data within the cloud. So let's do a little bit of history here. We'll start with the 1960s. This actually is the origination of the cloud, traces back when some engineers started to envision this idea of power provided on demand and scalability when it comes to computing power, because at that point, computing resources were very limited. They were limited to location, they were limited to the number of users that could use a computer consecutively, all of that stuff. So it just made sense to think outside the computer box, if you will, and look at what we could do by sharing resources and sharing them regionally across the world. And that is what gave birth to the idea of cloud computing. So again, time sharing played a big part in that. How can we share computing time? We've already looked at how that was done, creating that first password, that first username. So advancements came quick, 1970s, 1980s, towards, the 80s. We end up with virtualization. And the reason why virtualization is so important to cloud is the fact that it allowed us to use these hardware resources for more than one purpose, for more than one operating system. We could create, as we know, a base, okay, as we've already discussed, a host operating system, and then virtualize many machines on top of that for unique purposes, right? This also created some segmentation that is important to security as well. And of course, all of this works because what took off was TCP/IP and networking. Okay. Now, I'm so old, I actually remember Novell and IPX, SPX. That's where I started my networking career before TCP/IP. So we started with Novell, which was Linux-based. Unix-based or Linux-based? I don't remember. Everything in computing advances so quickly. I mean, just look at how old the internet is. Look at how old cloud computing is. Look at how old AI is and its current impact on computing and all technologies, right? So, take us to the 1990s, pivotal moment. This accelerated the evolution of cloud computing by providing the necessary infrastructure for cloud services. We ended up with grid computing. We ended up with the idea of application service providers. A great example of that is Salesforce. So towards the end of the 90s, here comes Salesforce. It delivers the first software as a service model. So no longer did we have to download, get a server, install a database for Salesforce. It all ran from the cloud. Always when I say the cloud, I've got up my air quotes, right? Because it's not really the cloud, but it is. That's how we refer to it. So advancements again, 2000s come. Here comes Amazon Web Services. Amazon ends up with, due to virtualization and due to application provider, all this stuff, they end up with a bunch of hardware. And they start this idea of cloud computing, where they create data centers with hardware that they had that they were no longer using to run Amazon because of virtualization, because of efficiency, because of technology advances, and the cloud is born. Suddenly they're able to give you space on the internet for your applications, for your data, for your files, that suddenly are accessible everywhere when we stopped programming for the client-server model and started programming for a web-based model to data access. So AWS on-demand computing comes about, Elastic Compute Cloud, that's what Amazon called it. Other major players, we'll look at all of these players in detail. Each one has sort of their specialization, if you will, and we'll detail that a bit later. So mainstream adoption, here comes 2010. We've got, hybrid, we've got multi-cloud strategies. We're going to look at all of those. What does it mean to be public, private, on-prem, hybrid? A lot of companies run hybrid clouds so that if their internet connection fails, they're still able to function internally as a business. Really important these days, right? Because the internet is going to fail at times. Usually with, here in Bend, it's usually our ISP, TDS, that goes down for 4 days because they don't have redundancy, and, a local fire takes down something that takes down an entire city of internet. So, cloud usage definitely grew during this time. It became more important to secure data, to encrypt data in the cloud. I've got some data points to share with you that might shock you as to how little data is secured in the cloud even today. So these are 2023 numbers, just 1 year ago. Multi-factor authentication, advanced threat detection goes into the cloud. But again, the advantage for small businesses by putting this information in the cloud is that it's secured by an organization, i.e. the cloud service provider, that has the resources to do IPS and IDS and SIEM that small businesses may not be able to afford to do. Thus, as long as they're keeping their part, they're doing their part to secure their data with, great passwords, great usernames, implementing multi-factor authentication, auditing, etc., their data is almost more secure in the cloud. Notice I said almost more secure, right? If an attacker wants in, if a hacker wants in, a hacker's going to find a way in. It just depends on what the reward is, how much time and investment they're willing to spend. So, 2020s, we start getting into edge computing, which we'll take a look at. That's processing closer to the data issuance itself, as we'll see. And then, of course, Internet of Things explodes data centers. It explodes the cloud because all of these devices are communicating back with servers. A great example would be your Ring cam at your house. All of that video isn't being stored locally on the Ring cam, it's being stored in the cloud. Thus, you buy a service. Thus, there's a recurring revenue there, that was heavily created by the cloud, right? We no longer buy Quicken one time at $199. We use Quicken every year for $99. That's reoccurring revenue, and that's what's financing cloud. So that's it for this time. Next time in part 2, we'll be taking a look at Section 8.2, Cloud Fundamentals. We'll look at models, redundancy, and key providers. I'll see you then. Take care.